Okay, so this is our second series on questions from linked accelerations. So in today's question, a block of mass, 5 kilograms, rests on a smooth horizontal table and is connected over a string, and is connected by a string over a pulley to a hanging mass of 3 kilograms. What is the acceleration of the system? So the options provided here are 2.05, 3.5, 3.75, and 4.0 meters per second square. So we're going to solve this as usual and we find out the option that bears the correct answer. As usual, we would need to put up a diagram real quick. Okay, following the diagram here, we can see the forces acting on these two objects. Here we have a tension T2, here we have a tension T1. We actually have the weight W1 of M1 and we have the weight W2 of M2. But in this question, the weight of W1 is not going to play any part in our solution because the mass W1 is moving horizontally while the mass W2 is moving vertically. So this weight is not going to play any role in this in our solution. So what we are going to do simply is to write second law, the second law equation for both masses. So to do that, we should have, for the first case, we have the net force, which we know that results from two or more forces that act on the body. So that unbalanced force is always called the net force. So in this case, we are going to have net force is equal to MA. Since we are talking about M1, we add 1 here. This will be equal to, since the motion is going to go down here, then it is in favor of T1. So this is going to be equal to T1. There's no other force that acts on this object in this direction apart from T1. So this will stop here. If we substitute, we have 5A is equal to T1. That is for this mass. Then we go to the second mass, which is going to be moving vertically. So the motion is down this way. So we are going to have, this is our equation 1, please. We are going to have net force is equal to MA. Here we are talking about M2, so we add 2 here. This will be equal to, the motion is in favor of this weight, W2. So we will have M2G. The motion is against the direction of T2, so we have minus T2. When we substitute into this, we are going to have 3A is equal to 30. That is assuming that our G is 10 meters per second square. So we have 3 times 10, that gives us 30 minus T2. So if this string is an inextensive string, the tension this way will be equal to the tension this way. So we will simply say that T1 is equal to T2 equal to T. And if we have it this way, then we can now check where we have T1 and T2, we'll just use T. So from equation 1, we will do a substitution into equation 2 in order to complete this. So what we should have next is, T is equal to 5A. So we substitute this in equation 2. So we say substitute in 2. If we are substituting in 2, we have 3A is equal to 30 minus 5A. Since T1 is the same thing as T2 and is equal to T. So we will have 8A is equal to 30. That gives us A equals 30 all over 8. And when we work that out, we're supposed to get A is equal to 3.75 meters per second squared. So if we check that up, we will see that that is option number C. That is the correct option, 3.75 meters per second. So in the next problem, I'm going to take you through exactly this type of question, but in a case where there is friction between this block here on the table and the table itself. In this case, we work on a smooth horizontal table. So in the next example or the next question we're going to take, we look at a rough table where there is friction between the block and the table. If there's any other type of question like this that you have that you want us to solve together, just drop it on the comment section and I'm going to solve it and explain it. Like and follow for more videos like this.